When you're working with decimal numbers such as 3.1, 5.56, or 3.141592654, you're using what Swift calls a floating point number. This unusual name comes from the way computers store these numbers. They're designed to hold very big numbers like 100 billion and very, very small numbers such as 0.000000001 in the same memory. This is hard to do, and so they literally move the decimal point around up or down as needed for the number, hence the name floating point. The point floats. Now, this storage method is notorious for causing problems for programmers, and you can see exactly why, a little taste of it in just 2 lines of a Swift playground. Let's try it out here. We'll say let number equals 0.1 plus 0.2 and then print the number out. Question is, what will that print? When I press play, answer 0.300000004. It's not 0.3. It's 0.3, then 15 zeros, then a 4, because, well, like I said, it's complicated. I'll explain more on why it's complicated later on, but first let's focus on what matters. When you make a floating point number like we have here, Swift considers this to be a double. That's short for double precision floating point number, an even more odd name. And it has that name because the way we've handled floating point numbers has changed a lot over time as computers have grown in power. And although Swift does a fairly good job of simplifying a lot of the mess, you'll still occasionally meet some of this complexity out there. It's not avoidable. In this case, Swift allocates twice the amount of data as older languages might do, hence double. It has double the data. So it can store absolutely massive numbers or increasingly tiny numbers. Second, Swift considers decimal numbers like this, doubles, to be an entirely different type of data from ints, integers. After all, integers are always 100% accurate. 1 plus 2 is always 3. Decimals, doubles, as you've seen here, are not. There's a little bit of inaccuracy in there, and so it won't let you add them together or subtract them or multiply them whenever you want to by accident. You've got to be really, really precise about it. In practice, this means you can't write code like this. Let a equals 1, an integer. Let b equals 2.0, a double. Let c equals a plus b. Now, obviously, we can see that b is an integer, 2, masquerading as a double. The 0.0 is basically irrelevant, but Swift still is flagging a big error. You cannot mix ints and doubles. This is called type safety. Swift won't let us mix types of data by accident. If you actually want this to happen, to add an int to a double, you've got to tell Swift explicitly it should either treat the double as an int, like this. I'll do int b. That'll work. Or treat the int inside a as a double. So I'll say add double a and b, like that. Third up, Swift decides whether you want to create a double or an int based on the number you assign. If there's a dot in there, decimal point, you've got a double. Doesn't matter if it's 0.0, if it's point anything, you've got a double. So we could say let double 1 equals 3.1, a decimal number. Let double 2 is 3131.3131, another decimal number. Let double 3 be 3.0, even though it's 0.0, it's still a double. But let int 1 equals 3. No decimal point, it's going to be an integer. Now, combined with type safety, this means that once Swift has decided what data type a constant or variable holds, it must always hold that same type of data. That means we can write code such as var name equals Nicolas Cage. then name equals John Travolta. Guess the movie. That's allowed. We've told Swift name will hold a string and then made it hold a different string. That's fine, that's how variables work. But this kind of code is not allowed. Name equals 57. That tries to put an integer into a variable that should be a string, so Swift's going to complain very loudly at us. Finally, decimal numbers have the same range of operators and compound assignment operators that integers have. So we could say var rating equals 5.0, rating star equals 2, or even 2.0. Swift understands 2 in this case is a double. Now, many old APIs use a slightly different way of storing decimal numbers called CG float, named after an older Apple framework called Core Graphics. Fortunately, as you'll see, Swift lets us use doubles and CG floats interchangeably. We haven't got to worry about it. You will see CG float across Xcode in various places. It'll say, pass me a CG float here, please. Just give it a double. Swift will do the right thing automatically. You can just ignore it. Just see it and think double. Now, in case you were curious, the reason floating point numbers are complex is because computers are trying to store complicated numbers using binary. And if you think about a number 1 divided by 3, the fraction 1 over 3, we end up with 0.33333333 continuous. It doesn't end. And you can't store that in binary. It doesn't work. It's not designed for that. And so we have a system that tries to create the closest approximation that it can in binary. This makes it extremely efficient. And the error honestly is so small, like 15 zeros, then a 4. The error is so small, it's usually irrelevant unless you're doing very precise mathematical stuff like landing a cruiser or exploring thing on Mars, for example. But at least you now know why Swift does not let us mix int and double by accident.